Morning, everybody.
Good morning.
Okay, Angel, I see that your video having difficulty again today, maybe?
I'm trying, but
No, not a problem.
Okay.
I just made you co-host. I have some stragglers, I'm sure, going to come in because I only see 17 of you guys here right now.
Great, thank you.
Hey, this is the last week. When we started this whole thing, I don't know how many of you can show me your hands. How many of you taken a summer school class, any summer school class in the past? Okay, and depending on what the class was, most of you then raising your hand realize the commitment, the demand. You get a whole semester done in 6 weeks. That's the positive thing. But I don't know how challenging this has been for you to get through the 6 weeks, but gosh, I think there's probably 28 of you left on the roster from 34. That's really good for a summer school class. So hopefully this whole experience of the online hasn't been too challenging doing a stat class. Anyway, so 1 week left. Let's see, you got 2 sections in chapter 10 and 2 sections in chapter 4. And if I'm not mistaken, I go back to chapter 9 for one more section. So if I looked at my assignment schedule correctly this morning, it looked like there's 5 sections left. A lot more topics I could touch on, go over if I had the time. But I always run out of time, so I've trimmed it down my course outline. Let's see, so that leaves us today. Well, really the instruction is just for 3 days. Today, tomorrow, and Wednesday. Those are your last 3 days of instruction for me. And then Thursday, from the looks of the schedule, it's group quiz day. And any questions you have for that first hour as well. And then group quiz. And then next week on Monday, a week from today, we'll come back, and that's, I'll call a review day. So you can come with any questions you have. And homework problems we didn't cover, topics that are a little sketchy, anything on the practice final exam, whatever you'd like to take a look at, that's your time on Thursday. And I'll stay here as long as needed. Our class is 2 hours and 45 minutes, so I'll stay up till that time because then my other class starts at 10 o'clock. And I'll do the same thing for them. And then around, I think it's around 3 o'clock on Monday, the final will be released. And then you'll have the typical 24 hours to figure out when to submit your answers, because the final then will be shut down on Wednesday at 3 o'clock. So that's the plan for the next week. And I'm not sure if, I haven't looked at your class to see if I have inputted the extra credit. I did it with one class. I'm not sure if, okay, Bobby's saying yes. So it's my other class that I haven't done it yet. So that threw in 20 points for everybody that are still with us. And I think the last column kind of gives you an indication of where you stand right now. Some of you might be a little concerned because of your grades on your tests are low, but don't forget, final exam, half of it replaces your lowest exam score. And I manually have to do that. The machine won't do it. So when the final exam's done, then Wednesday, maybe Thursday of next week, then I'll go through, take a look at everybody's test results and make some changes, polish it up, and then submit the grades. Okay, let's see. The last week, we looked at, not confidence intervals, well, a little bit, but hypothesis testing. And that was mostly it was all chapter 9 so far. Let's see, there's 2 different methods. You've got the p-value, which is the easiest out of all of them, and then you've got that critical value or critical method, traditional sometimes, where you draw the bell-shaped curve and visually it might be helpful for most of you, I would say. Be prepared to do them both somewhere, whether it's on the quiz and or knowing how to answer questions on the final exam. And final exam, by the way, is cumulative, so it covers everything. Let's see. So then you've got the mean when sigma is given, the mean when sigma is not given, hypothesis testing. One's a Z, one's a T. And then the proportion, which is always a Z. Conditions or cases you have to check first. Once you check the cases and conditions, if it's A-OK, then you go about setting up the hypothesis test. And don't forget that the author likes to leave the null equals most of the time. I think on the final exam, it could go both ways. You know, the alternate never has the equal sign. But for the null, the final exam could look like what most of us would probably expect, or it could just be plain old equal because that's the way the author did it. So be prepared to understand both of them. And then you either reject or don't reject, not the alternate, you reject or don't reject the null all the time. And in chapter 10, we're going to be doing the same thing, rejecting or don't reject the null. Chapter 10 is different that we're going to be looking at today. And yeah. So any general questions before I jump into chapter 10?
The homework, Jeff, you want it before the final, same day? Because
Yeah.
on the
Because what?
schedule, it's due today,
The homework?
I thought. Yeah.
Oh, I'll have to look at that. No, that's wrong. If that's in there, you mean on the Canvas it says it's due today?
Yeah, I think so.
Oh yeah, okay. So I'll go back, I'm gonna write myself a note and make that change for those people that are, no, it's not due today.
Okay.
Yeah, so just make it due, you know, the day of the final
Mm-hmm.
and the time the final is due, just like the other tests.
Okay.
I got to have it in at 3 o'clock on, what would that be, Wednesday? Finals on Tuesday. No, Tuesday. You're taking your final. So I release the final on Monday after the group, after review. Tuesday at 3 o'clock, your homework needs to be in as well as finishing up your final. So Tuesday at 3 o'clock.
I'm looking on Canvas right now, and homework 4, it says no due date.
Oh, okay, good.
Awesome. Thank you.
So I might have changed it. You might have seen it before. Sometimes I forget what I what I do and write it down. But thank you for that, for checking. But it is due. I'm telling you right now. Don't say, hey, no due date. I'll turn it in next semester. That'll be too late. Anything else? Any other questions about topics, procedures? I'll be here at 1 o'clock your time. I'll be here at 1 o'clock again from 1 to 1:30 if you need my help with anything. Okay, it looks like I got 22 of you now, a little healthier, and I'm not going to take roll today. So let's see what I got here. Good. I'm looking for my, hold 1 second. Yeah, that's what I'm looking for. So of course, we're going to start off by looking at the means. I don't think I'm doing comparing proportions. I'm thinking I just didn't have enough time. You get the idea of how it works with the means. Seems like that's the theme. There's always something about the mean and something about proportions. But for chapter 10, I'm bypassing comparing to proportions. And you can do that on your own outside of this course and see that its strategy is the same. Formulas are pretty nasty. There's new symbols. The setup, the format, the process is all the same, even with the confidence intervals that we'll take a look at in chapter 10. Anyway, when we compare two means, there's two different types. One is, let's see, when I say two different types, you got one that's the word independent and dependent. Those words will come up. The first time as a student, I always heard independent and dependent is in an algebra class, a beginning algebra class. Y equals mx plus b. Y equals 3x plus 2. Y equals 3x plus 2. Okay, that's an equation of a line. You guys learn in beginning algebra. Your instructor, you've probably forgotten, usually will say, okay, there's two variables, x and y. One is the dependent variable and one is the independent variable. So that's where you might have heard independent and dependent. For us, I would say the idea about dependent, because the two variables you're going to have is two groups. So for instance, male, female, those are two groups. Male, female. Let's say we're comparing heights, how tall everybody is. And there's, on average, there's probably a difference. On average, probably in this country, I would suspect that the average height for males is taller. That means greater than the average height for females, probably. So that might be my hypothesis that I would compare. So I'm going to compare the average height of males against the average height of females. Now, I'm not going to go around asking 200 million males and 100 and, well, whatever, the left, the whole population of males and females. I'm not going to do that. So you go around and sample again. Now, the thing is about that, the heights of the females have nothing to do with the average height of the males. They're independent of each other. They're independent of each other because you're not using the same people to test. You're using two different groups of people. And you could use a different sample size. I can use 50 female and 20, well, let's make it more than 30, 35 male. So you can have two different sample sizes for something that's independent. Dependent samples, when you're comparing two dependent averages, would be something like, okay, there's 22 of you there. Let's say I had you do your resting pulse rate. You put your finger wherever you can feel your pulse, your resting pulse rate. So that 22 of you, I'm going to count over a minute and I'm asked for a number and I record those numbers and you're my convenient sample. We call it convenient. So I write that down. Now I'm going to compare that with your active unresting. I get you good up and start doing exercises, jumping jacks or whatever for 5 minutes. Then I said, okay, now show me or tell me what your number is when you put your finger up here. And you give me another number. So of course, likely there's going to be a difference in pulse rates, but how great is that? That's called a dependent sample because I'm using you over again. So the same group of 22 is the same for both ways is the same. It's called dependent. One's dependent upon the other. And when I'm looking at this, the title looks like we're going to start with dependent. So that was an illustration of that. When you don't know the population standard deviations, okay, of course, we're not going to know that. So then you have to use the sample. And therefore, what test are we going to use if we don't have a sigma? Anybody? If we don't have a sigma.
T.
Right. T. Someone said T. Yeah. It's a T test. So when we don't know sigma, you always use T. If you do know sigma, you use the Z. So it's the same theme even in chapter 10. So you don't know population standard deviation, then we use some assumptions we call using that. And we're going to use the assumptions that the sample size, as long as it's bigger than 30, then it'll be a pretty close approximation to what the real average might be. All this said, finding confidence intervals and hypothesis testing between the averages and even the proportion generally are challenging. Now, for us, we're just going to use given established formulas. So that's kind of throws the challenging part away. We just kind of follow the bouncing ball, so to speak, and come to a conclusion at the end. But there is new symbols. There are new symbols. And then we're going to go through that as well. So I've talked about that. Oh, sometimes dependent are called matched pairs. Think about that. I'm matching up the same 22 people with the next scenario. Your resting pulse rate, and then you exercise, and then your exercise pulse rate. Those are matched pairs. That's what they call them. Okay, I'll let you read that on your own. Oh gosh, I'm looking at case. Yeah, that's true. Case 1, case 2. Okay, we're back to the case. I was thinking conditions, but I've used the word case, I think almost exclusively, if not exclusively, for the mean, and I've used conditions for the proportion to kind of separate the concepts out. Of course, there's a case 3, and case 3 says, you just can't do it at all. So we're going to ignore case 3 because I'll bet you all your homework problems are case 1 or 2. They're not going to be any case 3s. Like, you can't, why would they put in a great big paragraph, likely, problem, and ask you to do a bunch of things, and you test it and says, hold it, can't do a thing, and look at the back of the book, and the answer key says, you can't do anything. They probably wouldn't. So case 1 or case 2. Here's your new symbols. When I say new symbols, mu and x bar are the same, but it's that little d. Little d stands for difference. And when I look at the hypothesis testing, what's different about this? The symbol, mu sub d's, okay, that's the population difference, but 0, everything is a 0. Interesting. So you can think of this as like this one here. Let's see. I'll do this one here. No difference. No difference. What's another word for no difference, by the way?
Not equal to?
Well, it almost sounds like it is. There's no difference. How would you, there's no difference.
Equal to.
Right, there you go. Okay, so no difference is kind of a strange way of saying, hey, they're the same. The same. No difference equals the same. So over here, you'd say, well, there's a difference. This says it's positive. The difference is positive. And this one here, less than 0 on a number line would be negative. So the difference is negative. Now that's the average difference, and you'll see how this works as we go through some problems. And this one here would say not the same. Neither, you can say it's neither negative or positive. Basically, let's see, not equal to 0. Oh, either, I should say either. Not neither. Yeah, either. Because if it's not 0, it's either positive or negative. It's one or the other. So I would say when you get down to the two-tail, you'll see this is a two-tail, by the way. you're going to see the phrases. Usually it's like the word the same. Oh, they look the same, or they're not the same. They'll test to see if the differences are not the same. And then you'd say it's a two-tail. But most of the time it's going to be, you're going to compare the sample averages. When I say sample averages, when you look at the difference of the averages, as we go through this, it'll appear that the number is going to be positive number versus a negative number. You'll see that. And so most of the time it's these guys, the top ones. On rare occasions, it's the bottom one. And if it's these guys, it's a one tail, left or right. And then the information you find, let's see, if it's sigma's not given, you got to do a T. And if you have a T, you have to do degrees of freedom. And then you look down your degrees of freedom again, because the sample size is identically the same, right? Because you're using the same people. And it's n-1. You look in the chart, the table, and you go about your business. You do the same thing. After that, after you set up this funny hypothesis test correctly, everything else is the same as chapter 9. I can't think of anything that's different. You still make your decision, reject or don't reject the null. Based on the p-value is probably the easiest, but everything else is the same. That's nice. Okay, so now confidence interval. Oh, and by the way, there's the formula again, but I probably never use the formula. And you might say, the formula looks different. I'll show you this, why it looks different. Oh yeah, here. See how it looks different? Because you're missing something. You're missing this mu sub naught. So here's the thing that it took a while, even for me when I first did. Where did the mu? How did this become x bar divided by s divided by square root? How did that look like? Here it is right here. See how? And it's just the notation. These are the differences instead. Where did that extra piece go? So think about this. Look at it. Mu sub d equals 0, or mu sub naught equals 0. There it is. It's right there. It's 0. So if you put it in the formula and it was mu sub naught, for instance, that's always going to be 0. So if you use the formula and you're doing comparing means, this formula reduces down because that part will always be 0. That's the assumption. And you just have the one single numerator over that denominator, which is, gosh, what would that be? That's the standard deviation of the sample means. I think that's how we say that. S divided by square root of n, which basically that's what this one is too. And then I wrote this in, you don't have this in your packet, because I think our maybe the homework I signed, I might have signed it 1 or 2 problems on find the confidence intervals and make your decision. And if you make a confidence interval, for me, it's always going to be a two-tail. I'll say that again. Two-tail hypothesis test is a confidence interval that you're familiar with. Are there confidence intervals when there's only one tail? Yes, but I'm not covering that. Those are harder. So anytime you get a confidence interval, for me, it's going to be a two-tail hypothesis test. And that's what it looks like. You know how to fill in the blanks. Comes from the table. That comes from the table. You're going to have that from your raw data, little s. You're going to know what n is. This is called the margin of error, just like before. You're going to find this from your, say, table. When I say table, you're going to find this from your table feature. You put it in your list, and then you do a one bar stats, I think it is. So the question I would ask myself, and you would ask yours if you were a student, well, what are you going to type into the list? What are you going to type in the list? It's the result of the differences. Okay, result, what do you mean? Let's say I've got your numbers, I've got your resting pulse rate, and I've got your pulse rate after you've exercised, and I got everybody's. So the question might be, do I take your first resting pulse rate and then subtract your next pulse rate, which would be higher? And likely it's going to be higher for everybody, likely. And if you take a smaller number and subtract a bigger number, you get a negative number. So likely the average is going to be a negative number. So likely it's going to be a one tail because the difference is going to be negative. It's going to be a left tail, one tail left because they're negative. But if you swapped it around the other way and you went, oh, but what if I did the pulse rate like after, I got the after pulse rate and then I got a before pulse rate. Well, if you swap the position of those, then you're going to have a positive. Most of them are going to be positive and the average will be positive. So what do you do, Jeff? Which one do you subtract from the other? And you want to be consistent. I see Carrie. Okay, so Carrie's numbers, I don't want to go and say I'll take her first one and subtract the second one, and then I see Rose's and I take her second one and subtract the first one, because you're mixing them up. You got to be everybody's first one, subtract everybody's second one. You have to make a decision. So I'm just going to put it out there to you, or recommend. There's one exception that the author does that's kind of weird, and I'll explain that in a second. I'm going to say we're all going to agree that you're going to do post minus pre. You're going to do second result, subtract the first result. You're always going to do that. Agree to that. Okay, good. You're going to agree to that. I think I showed that over here somewhere. Yeah, here. You will always do post minus pre, after minus before. You're always going to do that. Always. Post minus pre, and you're going to see some problems that are set up that way. I mean, they're going to give you the tables and say, here's your pre results, here's your post results. Now do the problem. And you'll always do post minus pre. Or here's the temperature, I don't know, wherever you're, over there in Sonoma County. Here's the temperature in Santa Rosa at 8 o'clock in the morning, and here's the temperature in Santa Rosa, this is after the time has gone by, at noon. I wonder if there's a difference. Well, of course there's probably going to be a difference. It's going to be higher, but you're going to do the 12 o'clock noon number, subtract the 8 o'clock in the morning number. That's our agreement. There is one place that see, like this one, you'll get a couple of these. I leave it on there. I should probably take these problems off because it's confusing to students, because the back of the book answers not what you would expect. To me, when I read this, sample one, sample two, and they even set it up this way, to me, sample one is the first and sample two is the second. I don't know, does that make sense to you? Here's my first sample, here's my second sample. It seems like you would do sample two minus sample one, like post minus pre or after minus pre. It seems like you would, but the author doesn't do it that way. He just goes sample one minus sample two. That's the only time that he does it weird, I think, my opinion. And he doesn't explain why he does it that way. So I'm saying the text says sample one minus sample two. You're not going to do that. You're always going to do sample two minus sample one to make it make sense for practice. On the final exam, I'm not going to do a sample one and sample two because it sounds like I'll mix some of you up. It'll be word problems. And it'll be more like, down here, there's a before and an after, whatever that means. So it'll be much more noticeable, I guess we're going to call it. So if I gave you one or two problems for the sample one, sample two, if you want to match your answers to the back of the book, well, then you got to go 1, subtract 2. You would have to go 3, subtract 2.5. So I'll say this is the textbook way. Textbook. They'll do sample 1, subtract SAM 2. That's the way they do it. So if you did it that way, and I'm not going to solve this, I'm just going to find the differences. 3 subtract 2.5, that's a half. Nope, 0, no difference. This one is positive, this one's positive at 1.5. 1 and what is that, 2.5. So whatever the sample, whatever you're doing here, it looks like on average here, if I took the average of these, so I add them all up and divide by 5, it looks like it's going to be a positive number. It doesn't matter how big the difference is, it's just a positive number. That's all you're looking for. Positive means bigger than 0, so I would probably perform a right tail test on this because it's a positive number. Okay, so really this is not interesting, so don't solve. Okay, I won't. More interesting would be this one. So suppose we want to see if a diet drug is effective. Okay, that's, it'll always be there. Diet, whatever methods, eating habits, but even a diet drug. Take a certain pill. Is that going to help you lose weight? So they take the same people. They're going to do, hey, what's your weight before you even started? And then maybe 5 months later, you've been taking the magic pill, and you weigh yourself for them, and they want to see if there's a difference in your weight. Did the pill, was it effective? Did it actually, is it effective mean you lose weight? I mean, why would it be effective to have you gain weight? That's not, doesn't make sense. So common sense says, hey, I want to lose weight. So if I look at this, did Amber, A for Amber, 190 pounds, lose weight? Yeah, she did, after whatever length of time. Bill lost weight, and Carrie lost a little bit, almost the same, and David actually gained weight, so it didn't help David at all. And Esther lost weight, Frank lost weight, Georgia gained weight, Georgia gained weight, Harry lost weight, Ingrid lost weight, and Jeff lost weight. So it looks like, I think if I heard myself say that, it looks like 8 out of 10 lost weight, so it was effective. Oh, you might say, well, then it must have been effective. No, you want to know if there's statistically, like right here, they lost weight, but boy, that's maybe they had different clothes on or something. I don't know. That's too close to call. You might even say 5, well, that's 7 pounds. You might even say 5 pounds is what's too close to call? Like this one here is only 3. So you want to do a statistical test to make a determination whether or not, statistically speaking, there's enough evidence to show that they've lost weight. And then you go about your business as a researcher or the product to continue the product or stop it. So that's what they're saying. Is there evidence to support the company's claim that the diet drug does cause weight loss at okay, so the 5% significance level, you guys know that, don't you? Remember that? What's that the same as when they make that statement? Anybody?
95% confidence interval?
Well, that is,
0.05.
okay, so I'm going to go with the confidence interval statement first, and then I'll do the 0.05 person, whoever said that, next. So the confidence interval, that would only be a confidence interval, 95%, if in fact it's a two-tail for us. You might say, well, okay, I wonder if it's a two-tail or one-tail. Let's see. Boy, it looks like reduce. Like reducing weight is the key. It's not like the weight loss, there was no difference in the weight loss. The claim, it says effective. So that's where you have to say, what's effectiveness mean? Losing weight. That means it's going to be this symbol to me. So I wouldn't say confidence interval on this one. So then someone else said 0.05. Okay, what does that mean?
The level of significance.
Okay, tell me how to write that differently, though. I would agree
Is
with it.
Alpha
Thank you. There you go.
equal 0.05.
Yeah, so that's what I was hunting for. Thank you, Angel. Alpha is the alpha level. It means level of significance. It's the same thing. And that's the standard one you'd use anyway, isn't it? If you were never given an alpha or a level of significance, you were never given that, you always pick 0.05 anyway. Well, here they give it to you, and they want you to test the hypothesis, test the company's claim. So that's what we're going to do. I think on the next page, I continue the problem over here. All right, so first we need to calculate the differences. However, I mean, we can do that. However, to actually do the hypothesis test, as I'm saying down here, since the sample size is less than 30, we're eventually going to have to do a dot plot before we can finish the problem. So let's do the differences first. And remember, it's after minus before. Now, it's set up differently. You're going to be tempted to do 190 minus 84. You're going to be tempted, but you have to do it the other way. After minus before, that's -6. And I think if I'm doing this in my head correctly, -7, -1, +5. Okay, let's see, subtract that, 16, -16. Let's see, that would be -3, +5. I think that's -13. Someone, I'm doing this in my head. I'm not using a calculator, so someone correct me if I'm doing the arithmetic incorrectly in my head. -8. And finally, it looks like maybe -12. Okay, so now, before I even go any farther, I want to see, these are the numbers that you're going to put in your list 1. These are the numbers in list 1. And then we'll do a dot plot. So that one, I'm going to remind you how to do this. All right, so let's see. Now, when you type in your signs, this is a little reminder because it's probably been a while since you've typed in a negative number. You've got two, I'm calling negative signs, but really one's a negative, one's a subtract sign. Okay, that's your subtraction sign. You're not going to use that because you'd have to have 2 numbers on either side of the sign to write it. This is your negative sign. So anytime you say negative number, that's the one you want. If you accidentally use this one, well, you'll get an error because the calculator says, hey, I don't understand that. So that's the one I want. There's actually a difference in the size too. I don't know if it'll show it here. It's probably too small. Let's see. No, I think it'll. Okay, you see the position and the size, there's a difference. So the long one, maybe if you just typed it out once, you're not going to see the difference, but there is a difference between the two. Anyway, most of you probably get that anyway. -6 and so on. Okay, yep, there's 10 problems right here. I noticed my 10. And then, so now I want to look at the dot plot. So what we're going to do is go back to the stat plot. I want to set this thing up because I could have lost some stuff. I don't want to do Zoom 9 yet because it's been a while. So I'm going to go second stat plot, make sure, yep, okay, looks pretty good. It's on, but again, I want to check to make sure, yep, you know, the bottom right corner is the one I want for this, still for chapter 10. And everything else looks good. So as long as it's on and the bottom right corner is highlighted and everything else should be fine, I can do Zoom 9. And other than that funny one right there, everything else looks straight. So Yeah, if I ignore one of them, looks pretty straight. So I'd say looks pretty normal, approximately normal. So based on that, if you were to, I might ask that on the test, just to see if you can do your dot plot right. Maybe I give you 4 dot plots to choose from. Which one looks like yours? Well, if you did it wrong, you'd say none of them looks like mine. Which one should be the right answer, and you'd pick the right one. Yeah, I'd have to think about how I create a multiple choice question to do the dot plots, but I can. It would be something I can do. So let's see, we would say case 2, dot plot appears STRAIGHT. So approximately. So it looks like it's approximately normal. All right, since we've established normality, then I'm going to set up my hypothesis test. And notice the new symbol, because it's not just plain old mu. We're just looking at differences. It's a notation for differences so that the person looking at your paper understand you're comparing differences. Oh, okay, comparing differences. This one says, it looks like it's negative. And hopefully the claim, that's what you want to try to do, is get the claim to be on the alternate side. Because as you remember, you're always talking about the claim at the end. The interpretation is always about the claim. And that's what the company, the drug company, is basically saying. They're claiming, yeah, it's reducing weight. This has got to be flipped around, but don't forget that the author might sometimes make that instead of just what you would expect. They would put equal there instead, and it doesn't matter. Okay, alpha level that Angel had reminded us, it's alpha is equal to 0.05. Okay, p-value, data value, critical value, finish the problem. Okay, now finish the problem is in part going to be a bell-shaped curve. And you'd have, again, we're back to 0, 1, 2, 3, and so on. So then we need a, well, typically I always listed the critical value first. It doesn't matter which one here, but I'll do this one first. So that would be a T crit, and that's still table D. And don't forget, it's degrees of freedom is equal to n-1. So that would be equal to, let's see, 10 subtract 1, so that's 9. That's not your T crit. You'd say, okay, T crit from the table would be, no squiggly, I'll just use the table answer, equals. And, oh yeah, in the back of this packet.
1.833.
Okay, now I'm gonna hear, I heard someone 1.833. I need someone to confirm or disaffirm.
That would be one tail, right? Yeah.
Yeah, so this is a one tail left, actually. Because it's less than, so one tail left. So this would have to be a negative. So is anybody disagreeing with whoever, and I heard somebody.
No, that one was in the homework.
So not 1.833, not that one. So what are you getting, Tate?
Oh no, yeah, it is. It is 1.833.
Okay, thank you.
It was in another problem that was in the homework. I remember.
Okay. So negative 1.833. Then I find that on the right here. still your rejection regions there. And then what you're going to do is then find the t data, squiggle, squiggle, and your p-value. So now I'm doing this. Now, here's the thing, as I'm looking through my choices right here, turn the darn thing on. I know it's in my list one. I know I'm going to use list one. If I go to stat and I do tests, here's the thing. You're looking, see this 2 sample thing right there? 2 sample? You would, you're apt to think you're going to pick number 4, and that's not right for chapter 10, section 1. So if you want to write yourself a note, number 4 is for chapter 10, section 2. That one there is chapter 10, section. Yeah, but Jeff, I'm doing 2 samples. Well, you are, but because I end up having 1 list, 2 samples means you're going to have 2 different lists, and we're not there yet. We only had 1 list. So this is going to be your t-test. You're going to use number 2. So for 10.1, or if you're on your final exam, you say, okay, gosh, is this going to be dependent or independent? Because I'm not going to tell you it's a 10.1 or a 10.2 test. I'm not going to do that on the test. That's all part of your learning. Can you decide which one's dependent, which one's independent? So if it's dependent, and you say, yes, I know it's dependent, just have written somewhere in your notes that dependent uses a t-test number 2. So this one's, I'm going to use this one. And then I'm going to do data, not stats. I'm use the raw data. And it's going to draw from list 1, which is what I wanted. You guys probably have forgotten in like 2nd day or 3rd day of this course, you know, that say, hey, I'm always going to use list 1. I'm never going to use list 2. List 1 is always the default. You probably didn't understand that until now. You probably forgot. Oh yeah, list 1 is the nice one. Because if you did list 2, you'd have to type this in as list 2. I mean, it's easy to do, but you'd probably forget. So everything in list 1. Now, Jeff, this doesn't, you know, muse of not is, I've got this muse of D thing going on. Just blank it out of your mind that it's not. It is this number. Where is it? Oh, it's 0 right there. That's the number you're going to type in. So make that 0, list 1, frequency is always 1. I want that choice of a symbol, that one there. And then calculate, see what we get. Okay, there's my data value. I just want to know if that number sits in the rejection region. So like rounding, Jeff, where do we round? You know, if I'm really, the goal is to make a decision and I don't care about the numbers all that much, I'm just looking to see if that's to the left of that. That's all. And it certainly is. Who cares about the rounding? It is. But I'll still stay with the rounding just because you guys are still maybe scared. Like on the group quiz, I'm going to penalize you for rounding incorrectly. Yeah, I'm kind of beyond that now. When do you round 4 decimal places? Likely. What have I trained you? Usually 4 decimal places. What type of scenario?
Probability.
Right, probability. So good. Suman remembered that. That's probably enough out of the course to remember probability. Why do we have to do 4 decimals of probability? Only because of the table that you have. Could you have just done probability to the nearest, I don't know, 10th? Won't be as accurate, but yeah, you could have done that in real life. And so the p-value, which is really a probability, I mean, see, look at that. If I did 1 decimal place, if it did the probability of 1 decimal, wouldn't you say it's 0? That's not accurate enough. If I did 2 decimal places, that's like 0.02. 3 decimal places is 0.018, kind of close to 0.020, kind of, see, so pretty soon you get out there, how many decimal places is kind of okay. Well, I don't know. I'll do 3. I'll do 3, just to be different. Because all I'm doing to make a decision, I'm looking to see about alpha being 0.05, comparing. And really, and when I looked at 0.02, it was still less than this, no matter what. Maybe your rounding helps with the placement of this number and how close it is to here. So how strong your rejection is, maybe. That's where you might want to have your rounding a little bit further. How strong a rejection? Like, would this make a difference if I made this 0.0? Well, of course, that would be like a super strong rejection. But 0.018 is a strong rejection, but it might not be super strong. This is your alpha over here, of course. Then we go over here and say, where does the data value sit? It sits over here. And because the data value is to the left in the rejection region, you say reject the null. And we go back to that wordy thing, and that maybe a few of you are still hung up. You've been working your homework over the weekend, and to try to match up words in the back of the book, I don't know if I would always try to match that. I would do as close as I could to the back of the book because it's kind of like a guide. Excuse me. But oftentimes I would say there's enough evidence or sufficient evidence. And on the flip side, I'd say there is not enough evidence or there's insufficient evidence. That's kind of like a cookie cutter beginning. And then after that, I would end up finding my sentence structure on the top of the problem and kind of copying that over again. So reject the null, reject. Okay, so I'm rejecting that. Whatever I'm covering, I'm rejecting that. Reject that. Okay, but here's what the claim is over here. So it looks like there's enough evidence to show this. So reject that. Looks like there's sufficient evidence to determine or show or to support. I think they even say support up here somewhere. It's on the other page. Looks like there's enough evidence to support the company's claim that that their drug is effective. So something like that in your writing. And I would say, like, I don't know if there's a measurement of how, what's strong, what's weak. I'd say that's medium strength. I mean, I think I'm pretty confident. If I use confident, there, I'm pretty sure. Looks pretty solid. The closer that blue dot right there gets to the red threshold, weaker your decision is, the weaker. And the farther away it is, the stronger it is. So there's enough evidence to support the drug company's claim. What is it, a pill? I don't know if it's a pill. I'll say the drug, not the drug. Because I'm running out of room, is effective. Effective and weight loss. Ran out of room, but enough to put something down. Okay, any questions about what we just did?
So you said that this situation is dependent.
Yes.
That is one thing I'm still kind of stuck on that because to me it's pretty independent because the result and I mean we're supposed to be like one factor affect the other, but this is two different person, right? I
No,
mean this is
It's the same person.
it is at select 10 volunteers.
Right. So 10 volunteers, and they weighed all 10 volunteers, and this is their weight before they took the drug. The same 10 volunteers comes back a month later or 2 months, and the same 10, that's the key about dependent. The same 10 volunteers are right here. So it's the same group. When it's a different group, group A, group B, guys against gals, bananas and oranges.
Okay.
That would be independent.
That makes it independent.
Okay.
Thank you.
Yep. Oh, and dependent, by the way, the numbers have to be exactly the same so that when you subtract it, there's something to match up. Independent, one group could be a lot bigger than the other group. How do you subtract those? You can't. So you have to have a different way of determining what's called the difference. You have to have a different way of doing that.
Thank you.
Yep.
Jeff, just looking at the p-value, like sometimes they ask you how strong the evidence is,
Yes.
and looking at the p-value, like how much difference make it like really strong, how much difference make it like really weak.
I understand your question. You will have something like that in chapter 4, but our author doesn't give you a numerical threshold, a numerical number that gives you, if it was this far away as a number, the distance is weak or strong, and go here, it's stronger or weak. Our author doesn't do it. Is there something that's out there in the real world? Probably. That's agreed upon by statisticians? Probably. So I would say right now for our course, you don't need to use the word strong or weak until chapter 4. Chapter 4 is a little different. And then you will be given a range of where the word weak would be, where the word strong would be, and then the other scenario, I think they say there's no difference. Like there is no change because it's too close to call. But in the real,
Jeff, I was gonna wait until next hour just to ask the question because in one of our homeworks, the writer has asked about it in 9. I have to see which one it is, but I think it is 9.3.
yes.
Yeah, there's like 31 to 39. There are odds, and the question is use the indicated value to assume the strength of evidence against the null hypothesis.
Yes.
And the value is of p-value. That's the only reason I asked you.
Okay, thank you. And let me get my textbook and see what you're looking at. And I might flip back a little bit. So I might stand corrected. The author briefly says it, and that's why he puts it in there. So give me a second, get my book. Okay, 9.3.
521, Jeff.
Thank you.
Number 31.
I do see those. Thank you. So I'm flipping backwards in the section for a moment. Still looking, still looking. Oh, okay. So they do have it. I stand corrected on page 514. So I stand corrected. P-values, yes, they have it right here in table 6. So there you go. There's
Okay, Jeff, because every time I punch in table 6, it would took me to a different table. That's why I couldn't find that. But yeah, I can see that. Thank you, Jeff.
So I stand corrected. I was just giving you, okay, p-value. So see, they're giving you, it might be harder for some of you right now, which I would make a lot of you, to say, you know, alphas, like this is an alpha. There's an alpha. You know, which one is alpha? I would think maybe if your alpha's between here, so these are alphas, 0.01 and 0.05, your p-value is there. If your p-value is like, think about p-value being close to 0. Well, there's like ridiculous against the null. Like when I say evidence against, that's like reject the null, reject the null. Yeah, oh yeah, they're super strong if it's like 0. And of course, it doesn't show anything about being greater than unless you go this way. So if you look at, find my pen. If I look at this way from right to left, it's harder for most all of you to read right to left, especially in algebra. Students always get it wrong. They read it from left to right and say 0.05 is less than the p-value. That's not wrong, actually, to read it that way. But if you're just thinking p-value this way, that's usually the way you want to see your p-value and compare it against the alpha. So if the p-value is bigger than alpha, then you reject the null. But if this p-value is less than this alpha, then you say, I don't reject the null. And that's kind of what they call moderate, solid, I don't know. You know, lots of different English words we can use. Don't worry too much about this, except for your homework. I get what you're saying about your homework. The big thing will be in chapter 4. Or that's where I'm going to bring it up about the strength in chapter 4. So the rest of you, now you know where those problems 31 through whatever number it was that Suman had brought out. Just do it and compare it right here. And use these words. That should be the back of the book's answers. Thanks for asking that, Suman. Now I will know or be reminded. I probably knew it. I just had to be reminded because I never use it in my teaching this. And I'll be reminded in the fall semester when it comes up again. Okay, moving on then. I think we're still in the same section. Okay, I found this on the internet in terms of, you know, this particular problem. I just thought it was funny, made me smile. I didn't make this one up. What's the matter you? No, what's the matter with you? Okay, nobody's laughing. Okay, fine. What's 5Q? I think I've done this with you guys already, but some of you are still thinking, oh yeah, I didn't get that. What's 5Q plus 5Q in algebra?
10Q.
You're welcome. Happy to give you the answer. So that's like a stupid joke. This is like a stupid thing, you know. What's the matter with you? What's the matter, university? So that's the only reason why I grabbed this one off the internet. I borrowed it from, or stole it from somebody else. I don't know if I have or not, but probably heard about the freshman 15. I personally have never heard that, but maybe it's out there for you guys. The weight gain many students experience in their first year at college. How about this one? Now, I don't mean to make light of what's happening in the world right now, but maybe it might say COVID. COVID-15. I've gained weight. People talk about, I've gained weight just sitting at home, being sheltered in place or not getting extra. I don't go to the gym. So anyway, COVID, yeah, I got 15 pounds I'm carrying around extra. I don't like it.
That's accurate.
So, or 15, or COVID 20 or COVID over something, overweight. Freshman 15. Okay, the weight gain many students experience in the first year of college. Okay, the Urban Dictionary even talks about whoever they're, I mean, I've never checked this out. I mean, might be something for me to do back in 2004, but I never have. Anyway, Francine wanted to know if that was really a real thing or just an urban legend. During the first week of school, she got the other 9 women in her chemistry class at the university to agree to help her collect data. And she reasoned that students in any particular class would effectively be a random sample of the school, since class choice is unrelated to weight. Oh, so it's not biased. Oh, for instance, if you take I don't know, you're taking a phys ed class that's on cross country running. Probably that's going to be a little skewed because the cross country runners are pretty thin, probably. But because, or even they say a cooking class or a spin class or something like that. So anyway, she thought it would be reasonable just do a convenient sample. Convenient. All right, so let's see, student A, B, C. Okay, there were what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, including herself, I think. So maybe there's 9 plus hers 10. So they went here and said, okay, September. So this is before. This is the beginning of the freshman year, and this is at the end of the freshman year. So this might be start, finish, S-T-A-R-T, finish. What's some other words you could have used? Beginning, end, before, after. Remember, for us, we're going to do always after minus before. So it's the second number I'll start with first and subtract. So that's going to be a positive number when I'm done. All right, anyway, she collected the data, realized she didn't know what to do next. If she just had one set of numbers, she would do a student t-test. Okay, got it. Why? Because the sample size is too small, since she doesn't know the population standard deviation. But what to do with the two lists? She had a brainstorm. She realized she's not trying to find out anything about the student's weight. She just wants to know about their weight gain. Looking at their weights, she had plenty of she'd have plenty of lurking variables. What the heck was that? Starting with pre-college diet and lifestyle. Okay, those are like, we're not going to get that deep into it. Like what's actually also causing it besides just being there? Yeah, they're looking at only the weight gain, minimizes or eliminates those. We're just not going to do that. We just want to see what happened to each student during the freshman year. Okay, so she added a third row to her chart, which is the differences, just like we did in the previous page. So I'm going to flip the page and fill it out because I think it's the same chart. We're going to fill it out. Flip the page. See if that's true. Oh, no, it isn't. Okay, so I'll fill this out. So it looks like I need to take the result. Shoot, when I make these copies, now I'm going to have to take all these numbers and flip it over and do something with it. So I think what I'm going to do is I'm going to put all the numbers in, use my calculator to generate some results before I flip the page and see what I'm being asked to do. 125 subtract 8. Okay, some of you are saying you're doing this in your head, Jeff. Fine. I take the I take the second number. Just make sure everybody's seeing that I'm taking the second number and subtracting the first. I'm not doing it the other way. Some of you are going to do it because you're not either paying attention, you're asleep, you forgot, you didn't write it down. You're going to get -7. You're going to write that down. And so anyway, yeah, 7. And then someone just you've already done this, I'm sure, a few of you.
9, 5, 10, -1, 13, 4, 4.
Yeah, I know I wrote 14. Just keep going. I'll erase that.
6 and 9.
6 and 9.
Yeah.
Okay. Scratch. My whiteout is not
There you go.
accessible. Yeah. Sure. If I looked at that, everybody gained weight except one person somehow lost weight, but everybody else gained weight. Okay. Looks like it's not an urban legend right now. They gained weight. Now, what am I going to do? From the last problem, I put that in list 1. type it fast. Sometimes I go back and check, especially if there's only 10 numbers. I go back and check against my original, make sure I didn't put like 14 right there, accidentally because it was in my head. -1, 10, 5, 9, and 7. Okay. So now, since it's less than 30, I'm going to have to go and use my dot plot again and see if it's approximately normal. So I'm going to go second stat plot just to make sure it's on. Yes, it is. Hit enter. Make sure that hasn't crawled around accidentally and went someplace else. It looks good. So now I can go zoom 9. Yeah, looks pretty straight. Looks pretty straight. Suman, here's the other thing too, because you were asking about the strength, like the p-value. In chapter 4, we're going to have plots that aren't called density plots. They'll be something a little different. Like in algebra, when you graphed lines like y and x to make a t-table and you plot those are called scatter plots. Anyway, you're still going to look at the line, if it's kind of linear or not, but the calculator is going to give you a number, kind of like a p-value, but not. It's going to give you a number, and your author will then say, determine the strength of your decision, which would be, again, reject the null or not reject the null, but determine the strength, chapter 4. But the number won't be a p-value. They're going to call it an R. Instead of a p, it's going to be called the letter R down the road. But that's chapter 4. Oh, so I've got that. Looks good, approximately normal. And then I can go into stat, might as well because I'm going to do it anyway. T-tests. I want the data. And for us, that'll always be 0. But I don't know which one of these I'm going to pick. So I'm going to go to the next page and start setting up my hypothesis test before I hit anything else on the calculator. Okay, let's see. Alpha, I don't know if this freshman, whatever her name is, Francine, picked an alpha. I'm looking in it. I can't see one here. So we're going to say Francine then knew she's going to go 0.05. And then we do a bell-shaped curve. And then we want a hypothesis test. So H sub naught, H sub A. Appropriately do the new symbol. Now the new symbols are just mu. The new symbol is mu sub D. And here's where it's different. Well, not different. Let's see. Is gaining weight or losing weight what we're looking at trying to determine? Gaining weight or losing weight in this example?
Gaining weight.
Yeah, gaining means you're going to be greater than. So this is like the word gain. So gain weight. That means this one's got to go, well, shoot, Jeff, can I just do that? Yes. It makes no difference what you put over here, as long as it's an equal sign. It makes no difference because you're not going to talk about this at all. You're just going to either say reject or don't reject. You're always talking about this one. And this will be always 0. Always 0. For the differences, that's what you're comparing it against, is whether it's bigger than 0, which is gaining, less than 0 is negative, that means losing. Or they remain static. Looks like the weight, like one person didn't look like they lost much weight at all or gained any, like basically remain the same. So maybe all of them remain the same, and that was really an urban myth. So it's a one tail right. So 1, 2, 3, 4, 5, 7, 8, 2. So T crit, okay, degrees of freedom ultimately is the number 9. That's because it was 10 minus Oh, maybe, was there 9? Oh, there was 9 extra people. Yeah, there's 10. 10 data values. So ultimately it's 9 on the chart. You look at alpha and a one tail. Someone's going to give me the number. And then if there's any disagreement, we'll talk about it. Remember, alpha's 0.05, one tail.
Would it be the same?
The same one. Yeah.
1.833.
1.8. Oh, same one. Interesting. Okay. Well, that's makes sense if I'm using the same alpha and the same n number, so it makes sense. Positive or negative, though?
Positive because it's going right.
Correct. Well, that was weird. Don't put an asterisk, Jeff. That was weird. Yeah, positive number. That the asterisk meant to be over here. Okay, now what I get to do is go on my calculator, knowing that I'm going to pick that symbol here. Oh, look at the p-value right there. It's probably close to 0. It's probably reject. Oh yeah, look at the, that's pretty far out. It looks like a strong. And I think if a Suman looked at that table 6, he'd probably see the word strong similar because the p-value is low, probably lower than 0.0001. I think it's 3 zeros. Anyway, all I have to do for right now is say the data, squiggle, squiggle, let's see, 5.3-ish, the P, squiggle, squiggle, 0.123, and then a 2, maybe a 4. Maybe it's not super strong, Suman. Now, I think that number on table 6 was a point, maybe there was 3 zeros and a 1. So it might be the next word down if I was going to choose the textbook choices. But I don't need to put the word strong. I don't need you to put the word strong for me for this problem. I just want, do you reject or not? And yes, you do. Oh, put the, this number right here goes right about there to the right. Reject the null. And since I'm rejecting this, again, I'm not talking about just saying, hey, make that go away. It's like, I believe this. I reject that, believe this. Like there's enough evidence to support whatever this is, supporting. Looks like there's weight gain. Looks like it's not an urban legend. Looks like there's enough evidence to show that freshmen or students in their freshman year do in fact gain weight. Believe. I think there's lots of words that you could use. Support might be a proper word. Believe, understand, determine, show. There's lots of different phrases, I think. To believe that there is, I don't know, in fact, wrap it up with some statement. And you can see what the author does for his as well to compare with what I'm writing down. Lots of different varieties. So on the multiple choice test, though, there's only going to be one phrasing, and they'll twist up the words a little bit, twist it up. You might take a look at the 1 or 2 or 3 multiple choice questions that are centered around the interpretation, because they'll probably all start sounding the same. You have to practice that. Okay, any questions on that one? Yuck, cold coffee. Okay,
Did you say 2-minute break to refresh coffee?
say it again, Rose.
I said, would you say 2-minute break to go refresh coffee? Okay.
I could, but I don't think my wife might have poured out the coffee and they go in there and I'd be disappointed. So I'm just going to wait till you guys take your little baby quiz, which I believe number 9 will be up for today. I think there's a number 9. Pretty sure. I'll take a look before we end class today. That's when I'll go get coffee. Okay. 10.2. So here's different problems. These are the ones that's called independent. And you're going to have some, oh my gosh, look at that crazy formula thing right there. Yeah. Good thing you don't have to ever use that by hand. But if you had to, that's what you'd have to do. Okay, well, you know all these variables at the top, except there's a subscript. All that says is what's the average of the first sample, X bar is sample. And what's the average of the second sample? And then we're going to do some differences. We'll subtract those averages. What's the average of the first population overall sample? I don't know. I'll never know that. This doesn't say mu sub naught. There's a difference there. So the question, and I'll have to explain to you what happens here in a moment, is, well, what the heck? Doesn't this feel like a, okay, it does. Remember the old-fashioned chapter 3? Chapter 3. When you first saw the Z formula, you went,
Is it me?
No, it's not you.
No, he
No.
just froze.
Sorry. Thanks.
Jeff, you just froze. Where'd you go?
Yeah, I think we cannot hear you, but we can see you now.
I bought up to the super speed, turbo
Oh,
speed
okay.
here, but why it kicked me out momentarily, I have no idea. So I did.
Did Xfinity put you in?
No, I'm buying it at the location here.
Oh.
I bought 4 days worth of super speed instead of the base. I knew the basic wouldn't have been adequate enough. But why? Anyway, I'm back. Is it being pixelating, by the way?
No.
Uh,
No,
regular
you're
break.
good.
Yeah. So I think it's generally good. Just for a moment, we had a hiccup. Okay, now I got to get back to my screen here. Anyway, I was implying that you guys have seen this formula in chapter 3. That looks really crazy, ridiculous, how they come up with the denominator. I don't know. You can do some research on it and find out. But it works. Works. It's accepted. So let's see. What the heck is happening here? Mu sub 1 minus mu sub 2 is always equal to 0. How come? Well, look at down here in the two-tailed choices. You see, that's the way I pointed out. Look at this. Mu sub 1 minus mu sub 2 is always equal to 0. Really? Well, yeah, isn't it equal to 0 here as well? Right here? It could be. and it could be there. So we're just going to assume this goes away. On, and then you're down to this small reduced formula, which again, I'll never use because I'll get my results from the calculator. Okay, so, okay, since it's a T, you're going to have degrees of freedom. Now, I'm going to have two different samples and most likely two different sample sizes. I'll say it again, but differently. The previous section, it was called dependent, and the sample size, the before and after, it's the same people. It's the same sample size, same people. 10.2, the sample size most likely will be different. Two different groups of people. If I said how many guys are in this class right now, likely, I mean, it could be exactly the same, but likely there's fewer or more than the women, likely. So then the sample sizes are different. And what you're gonna do is you're gonna take the smaller of the degrees of freedom of the two samples. Okay, so you're gonna have two different sample sizes, two different degrees of freedom, and the agreed upon is basically you're taking the worst case scenario. I'll say the worst case, you know, to either reject or don't reject the decision. We're going to take the worst case scenario for the T-crit. So take the smaller, and then you determine whether you've got one of those tails from your word problem, and everything else is the same. So here we go. Okay, so I borrowed this problem because it continued. Whoever brought this up a number of years ago, I said, oh, they're looking at 10.2 and they're going to continue with the same university. Professor Sullivan's students at the university felt that he was a tougher grader than other speech professors. Oh, students, not him. The students, you know, you rate my professor. Hey, it's a harder professor. So somehow they rated his classes, other speech professors against him, and they decided to test it. Again, there's my alpha, right there, alpha. So 8 of them took a 2-hour shift. Okay, what did that say? Okay, 8 of who? Probably students. Actually not, because here are the number of students. So if I look over here, it looks like there's a total of 86 students, sample size total. So some would say Sullivan was tougher than the others, and this would be the other professors that were harder. So it looks like the whole sample size was 86, but okay, what are we comparing? 8 of them each took a 2-hour shift, assigned randomly a different times a day as the week, distributed questionnaire. Oh, 8 of the students who have taken Professor Sullivan's, so it has nothing to do with the survey. They're just going around distributing the survey. And they felt that this was a reasonable approximation to a random sample of current students. Okay, they asked each student not to take a questionnaire if they had already submitted one. So they don't want to double dip. Questionnaire asked whether the student had taken the speech class in the previous semester, because if they didn't, then they probably say, well, you're not part of my survey. So we took a speech class the previous semester. They asked, okay, the professor, which professor? And they say, well, I guess they recorded it. So they did record whatever the results were, but they wouldn't be counted because they want to know the difficulty, like of the professor somehow in their questionnaire. So did they take it? No. Yes. Sullivan, other professor. And they would end up looking like they're going to do the analysis with categorical data of the letter grades. Ah, okay. So that's what they're doing. Basically, they're going to ask what their letter grade was in their speech classes in comparing that. So as you know, 4 points is the typical A, and they decided maybe this is a standard 3.7 is a A minus and so on. So we don't do plus and minuses at SRJC. I don't know if there's anybody brand new here. This is your first math class. But if you didn't know that SRJC, a C is a C. In my class, if you get 65%, you got a C. You didn't get a C minus. You didn't get a D plus. You got a C. And anybody who got a 79.9%, you also got a C. So a C is a C. So they found these numbers, and what they did is they did an average. So they've already done the work for you. If you didn't, you would have had to do the same thing. You know, put in the calculator for the Sullivan's class. Looks like 32 numbers in the Sullivan's class, and then found the standard deviation, the mean over here. 50 other professors that are speech professors. You put their raw data in and found out the average. Well, shoot, it kind of looks like the average grade looks like the other professors are, I don't call it easier, but they gave out higher grades. Sullivan's is harder and maybe tougher. It appears that way. But you're just not going to say, well, that he's a harder grader, because you only took a sample of 86 students. There was a lot of students that have taken them, probably. Maybe. Does it say him? Maybe it's a female. I don't know if it's a him or her. Doesn't matter. Yeah, Professor Sullivan.
Your audio's messing up, Jeff.
His audio's messing up right now.
Yeah.
Okay, I'm on the internet too. Not number one. Okay, testing. Still messing up?
Better.
Cleared up.
Okay,
It's fine.
I'm almost done, so that's a good thing. I'm sure all of you are going to be satisfied or happy when this thing's done, so you don't have to hear my voice all the time, Monday through Thursday. All right, here's the hypothesis test. Population number one would be the students, Sullivan students. And why one? Just because he's listed first, probably. Jeff, could I have listed the other ones first and then Sullivan second? Yeah, you could have. Could have. Could have. When I look at this, Sullivan's is lower. See, so had you, if you think about this, it's lower than the others. Okay, so the average grade is lower than the average grade in the other. If you went and did it the other way and said mu sub 2 is equal to, or population, pop 2 is equal to S for Sullivan, and pop 1 is equal to other, then you would have had to say mu sub 2 is less than mu sub 1. That's the difference. You would have done that. Sullivan is still lower than the other ones. But this is the way they set it up. Alpha's 0.05. Okay, so could you have done, yes you can, done this to be the greater than or equal to? Absolutely, that works perfectly fine. They say no difference. Since I went greater than or equal to, instead of saying no difference, that means the same, you could have said not lower than. Because this would say, well, the grades appear to be the same or more, like he's easier, because the numbers are higher for Sullivan. So it's either Sullivan's grades are lower or they're not. That's the complement. Okay, systematic. Okay, interesting. Remember how systematic works? Someone describe what systematic. Give me an illustration with maybe this problem.
I remember it was 1 out of 10 or 1 or 10% out of 100.
Okay, a little bit more detailed. Maybe somebody else describe it differently, maybe? You're in the quad. Students are in the quad that are giving out the questionnaires. The student, what are they? What's that systematic mean if they were given instructions. Systematic. It's been 5 weeks.
I don't know if I remember it correctly, but it was so every 10th of a student take the or no, it's not, huh?
No, you're closer now, Christian. You're closer. I think you got the right idea. It's just maybe put it into words. Let's say you
one out of
let-
every student, out of every 10 students that walks by, you ask one to.
there
Yes,
you go.
Oh,
So
okay,
you're-
I see.
There you go. So you're counting. If you decided every 10th student, you're not looking at gender, you're not looking at what their clothes look like, you're not having any bias. You're just counting. And if you chose 10th, then you stay with 10th. And you count 1, 2, 3, 4. Okay, the 10th person. Hi, how you doing? I just want to ask you a question. Have you ever taken a speech class? No, thank you. Okay, 1, 2, 3, and people walking by you. Okay, the next one. Hey, have you? Yes. Okay. Oh, okay. Have you taken Sullivan or somebody else? Somebody else. So you just record that and ask them what their GPA or their score or their grade was. Yeah, systematic means you're just every th, th, like 13th. You didn't have to pick every 10th. You can say every 5th person. So apparently that's, that was the idea here. Notice both sample sizes are more to 30 so that I don't have to put the data, raw data in to check the picture. If it turned out that the other ones, see over here, if this one turned out, hey, we're done because we're out of time, turned out to be, let's say, 28 students, you would have had to take those 28 students' raw data and put them in your calculator to see if the dot plot looked kind of straight. Because if it didn't, you need to take more students. You need to sample more students until you get over 30. Okay, so since this is 32, then we're good. It's approximately normal. And it's independent because here's what the person or on the internet that I grabbed off of makes sense to me. There's no connection between the Sullivan students and the non-Sullivan students. They're not the same students. Well, I guess another question says, well, if you didn't pass Sullivan's class, did you retake Sullivan? That could have been another question. Because if they got a D, if you guys get a D in my class, you're not passing. I don't know if there's any high school students here. This is your first semester. High school, still, I believe, if you get a D, you pass, you move on. Sorry, not an SRJC. You have to retake the class. You get a GPA, you'll get a grade point, something, but you have to retake the class. Okay, so we're assuming everybody passed here. We got numbers. All of this came from the results. And I'm going to show you how to do this, by the way. All of these numbers right here, blah, 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 right here. They gave you the results. Now, what if it's raw data and you don't have the results? I have one problem at the end of today that we have to find the results, and it'll draw from, and that's where list 1, list 2 will come into play. List 1 and list 2 we have to use. Okay, pooled. Well, you can do the reading. You'll always choose no. I'm not going to explain why you would use something. What has pool got to do with anything? I'm not going to explain it because you're always going to say no, no matter what in our course. And then, so this is where you're using the 2-sample t-test. I think it was number 4. Is that right? In your calculator, number 4? Here, I'll show you. Watch. Show you these results. Should match up.
Yeah, it's number 4, Jeff.
Stat, test, number 4. Okay. And then what we're going to do is use stats, not data, stats. So hit that, and then you just type things in that you have, the results. So, okay, here's my X bar. This is from Sullivan. And the standard deviation. And the sample size was, there's 32 students that took Sullivan's. And then that number. Pick one of these. Okay, I pick Well, that's why they reminded you what it was. Oh yeah, pick the less than. So it's a one tail left. That one. Pooled? No. No. Okay, it's highlighted already. Calculator? Yes. Okay, and it should have, yeah, it looks like this. That's the same thing. So just based on the p-value, you guys can do your own picture if you wanted to, but just based on the p-value, it looks like a don't reject, doesn't it? Just barely. P-value. Well, 0.06 actually is actually greater than 0.05. So don't, right here, don't or fail to reject the null. Don't do it. And so because you can't reject the null, you can't determine whether or not Professor Sullivan is a harder grader. You just can't. There's not enough evidence. Now it's a weak decision because probably when you look at the data, okay, see your t-score right here? T-data. If you went to get your t-crit, remember the t-crit is based on degrees of freedom, n-1. So since, let's see, 32 was, okay, degrees of freedom on this one is equal to 31. You can find that in your table, but this one here, degrees of freedom, df is equal to 53. You'd have to pick 50. And what do? Pick the bigger or the smaller one?
The bigger one.
Okay, let's double check. Wrong answer. Sorry.
My bad.
That's okay. You picked the smaller one. So we're going to pick the 32. What is it, 31? So you pick the 31. Don't pick the 50 some. Pick the 31. What you're going to do is go back over here. Oh, here it is right here. 31. Alpha's 0.05. One tail. Right here. Pick the 31. I think I get 1696. Yeah, I see Bobby saying yes, that's what she got. 1696. So if you did your bell-shaped curve right here, and it's a one tail left. So it's like over here, negative 1696, shade here. Your, this number right here, see that number right there? That's gonna go on, interestingly enough, that side of the number line, which is a don't reject. So you're still not rejecting. Now it's weak. Look at how close it is. I would say it's going to be a weak number. But don't worry about the word weak. Just not enough evidence to show that. Okay, the last one I want to do. Now I have time. I'm more interested in this one. I'm going to speak about this one maybe for a moment and why this is helpful. Okay, so I'll speak about this, but I'm not going to do it. And this is that resting pulse rate, and then you've got, smokers, non-smokers, and is there a difference in their heart rate and things like that. Okay, is there a difference? You see that right there? That's the equal, not equal. And that's when the confidence interval can be used because it's a two-tail. Difference will mean equal, not equal, two-tail. So then this is where you would say, well, gosh, how do we do a confidence interval to make a decision? It's whether or not because you'll have a confidence interval here, which really is the non-rejection region. Remember that? You did a confidence interval like this, but you guys did a number line. So you say right here, here's your confidence interval. And this is the non-rejection, can't even spell rejection, it's a J. Sorry, I'm butchering these words up. So it's like a two-tail, which would be like here. So the numbers you get right here would be giving you the non-rejection area. And then you're just deciding whether or not you're reject or don't reject based on the confidence interval. That's just an overview. I want to do with 10 minutes left, I'm going to do the raw data one to show you how to do that. I don't know. What do you think? Do you think there's a difference? I'm looking at 26 smokers. Okay, their average beat per minute is 80 smokers, 32 non-smokers, 74. It looks like they have a higher pulse rate. Smokers. I wonder if all smokers have a higher pulse rate or it's just a quirk. But maybe instead of the word higher, is there a difference? That's what they want to do. Okay, go over here. Last one. Here's saturated fat content in grams for pizzas sold by 2 national chains. Check the conditions. Oh, okay, well, I need to put those in. Here's what it means. Check the conditions. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, sample sizes are both too small. So conditions, maybe cases. That'd be better. Only because conditions was used for proportion and these are not proportions. So here's what you want to do. Well, here's what I'll suggest. Turn the darn calculator on, go stat, edit. Okay, I'm going to clear out list 1. We're going to call this list 1. And this one's list 2. That's list 1, that's list 2. All right, so with that, question from anybody? I thought I heard maybe someone. Oh, okay, there's list 1, list 2. I'm going to type these in from left to right, top to bottom. Okay, and then go to list 2 and type those in. I'm going to do. Gosh, seems like the numbers I'm typing in for PJ is most of them are a lot less saturated fat than the D. Gosh, just by the looks of the numbers. Anyway, we're going to do a at least a hypothesis test, and if there's time, I'll set up a confidence interval as well, because I see the word difference. Is there evidence that there's a difference? So I need to check the cases first. So this is what I'm going to do. I'm going to go into stat plot. Turn it on, sure. Okay, it's in the right place. But notice right now the default is list 1. So I'm going to check the graph for list 1 for the 20 data values and see if it's kind of straightish. So that means I go zoom 9 on just that one. Oh yeah, pretty straight, doesn't it? Yeah, so I'm going to say list 1, approximately normal. Okay, now list 2, how you do that, you go back to stat plot. And the only thing you need to change is tell the calculator to use list 2 here instead of list 1. So I'm going to scroll down. Okay, now I'm going to change that to list 2. Now I'm seeing there's like a, the cursor's blinking. It looks like there's a capital A in there for me. I don't know if you guys can, here, I'll zoom in so you can see that. See, A. Okay, alpha, 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 alpha. My alpha is all green on my keypad, not blue. Blue is the blue, alpha's green. So I'm looking down here for green. Yeah, you know what? I don't want any of those green things. I want blue list 2. I want that one. So I don't want the alpha. I want to change that to a second. And now I want the list 2, which is the digit 2. And it should be okay. Let's see if that did it. Yeah, so now I've changed to list 2. And then you do zoom 9. And that'll be your, what is it, 10? I don't know, however many, it was less than 20. Data values, you go zoom 9. Ooh, that was weird. What was that about? I don't know. Second quit. Okay, zoom 9. All right, looks pretty straight too. So both data looks fairly straight. So I'd say that one's approximately normal.
I missed it. How did we get L2 in there?
Normal. So you're going to have to do, if you look at your keypad tape, down here in the body, you're going to find all the L's. Mine are blue. I don't know what color yours are. Do you see your L1, L2s, things like
I
that?
see it.
Okay, so mine's and yours is probably placed on the digit 2, the button 2. So to activate that, you have to press your second first and then list 2 when you're in this stat, where was I? Mode. Okay, so you're into the stat plot. And I wanted this to be list 2, so you toggle down. Ignore the A right there. I have to hit the second and grab the list 2. So I'm gonna hit second list 2. And it'll replace whatever's there. Of course, mine was list 2, but it'll replace the list 1 with list 2. Then do zoom. Should be zoom. No, see, I did this. Okay, when I did zoom, I get this crazy thing. You guys doing the same thing?
Yeah, I got that too.
Yeah, so I didn't like that. I thought, oh, that was weird. So I just started over again. I went second quit, cleared my screen instead of trying to figure that out, which is weird. So I just went second quit or stop or whatever. Okay, so second quit. Okay, now do zoom 9 or zoom stat. Able to do that, Tate?
Yes.
Okay, good. And then what I'll do is I'm going to go into stat then, since it's approximately normal. I'm going to find the p-value. P-value 4 right there. Okay, now I want data, so I'm going to go over here, raw data. And the nice thing is it's going to draw from list 1 to list 2. Do we want pool ever? No. Oh, I don't know which one of these I need. Which one do I need? I don't know. I better set up the hypothesis test. I mean, I actually know, but. The symbol might be D again, mu sub D. It might be, it might not be. It might be just plain old mu. This is not equal to, and this one is equal to, and the reason is there a difference? And it's always 0. And that's a 2-tail. So pick this one here. P-value looks pretty small. So without drawing a picture this time, I'm going to say, gosh, reject that pretty strongly, reject that. And then there's enough evidence to determine that, well, okay, what's the word I want to use here? That the Yeah, I don't think it's differences. Now that I look at that, I don't like this right here. That's only for 10.1. I think
Jeff, isn't it mu1 minus
it is.
mu2
That is.
equals 0?
Yeah. Thank you. I just realized it. Yep. Thank you. Thanks for confirming. It's mu sub 1 minus mu sub 2 equals 0 versus mu sub 1 not equal to mu sub. Oh my gosh. I'm looking to see if that's the way that I had you do it here. Here. Give me a second. Yeah, it is. Some students, to wrap this part of this up, some students, if I said there's a difference, that means mu sub 1 is not equal to mu sub 2. You see that? That's like the word difference. And if you algebraically move the mu sub 2 to the left-hand side, don't we get that? The word difference, they're not the same. Is there evidence that the saturated fat content is not the same? No, there is a difference. This means the same down here. So then if I move this over algebraically, subtract that from both sides, then I do get this. Okay, that's kind of a defense of why that's true. And you can write that stuff in your own words. I think the last thing I'd like to show you is the confidence interval results, because it's a two-tail. So I go into stat, tests, okay, confidence interval. Now I'm looking for interval. Okay, they're down here. See that, the intervals? Interval. No, I thought it was kind of like two samples. Aha. Right, that's two samples. So I want the two sample t. Two sample t, because there's two different samples. Okay, hit that. And I'm gonna draw from list 1 and list 2 again. And I'm gonna go down, 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 down. Okay, confidence level. Okay, now if the alpha is 0.05, what do you think the confidence level should be?
95?
Right. That's right, it's the complement. So if the alpha was given to be I don't know where it was here, it didn't say. If the alpha is equal to 0.05, then the confidence interval is the complement, 0.95 or 95%. And if I'm not mistaken, it doesn't matter which one you use on this one.
Hey, Jeff.
Yes.
My calculator shows, I guess, alpha 1 and alpha 2. Yes.
Okay, did you do the raw data? Okay, we're gonna do this again.
Data.
I'm gonna go stat,
Okay. Stop.
tests. These are confidence intervals. So I don't want the word test. Don't use the word test in here. Don't use the word. It's a confidence interval. You're looking for the one, I'm looking up by screen here. You're looking for what's called two sample t interval.
Oh,
The reason why it's a t is you don't have sigma. So t interval.
Okay.
Yeah, you don't want the proportion, no. But so number 0, I guess it is.
yeah.
Hit enter and make sure you're on the data. Don't go to the stats. Make sure you're on the data one. And then scroll down. No. Okay, right here. The reason why that's 95% is because the alpha is 5%.
Yeah.
Go down, hit calculate, and then we've got this range of numbers. If it worked, yeah, I do. So you'd have something like whatever these numbers mean, 2.72 less than mu sub 1 minus mu sub 2 less than 6.7. Okay. Now, you guys okay with that so far? Because I'm almost done, but I'm not quite finished. Oh, by the way, reject the null. Isn't this reject the null from up here, from the p-value? Remember that? Yeah, so what I'm doing is I'm looking for, in the past, you guys have done this, but it's been a while. I'm looking for the number over here. That's why you got to set it equal, or over here, this number. I'm looking for that number. Does it sit in here? If the number sits in here, which it doesn't, 0 is not between 2 and 6. If it sits in here, then it's a don't reject. If it sits in here, if it doesn't sit in here, that's true, it's a reject. This is a reject the null because the number 0 does 0. Look at this right here. You see it right there? Use of 1 minus use of 2 is equal to 0. Is 0 between these two numbers? You say, well, no. Well, then you say, based on having done this before, we reject the null. If the number is not in between, we reject the null. That's a hard one to remember, though. Okay, yay, get to stand. Okay, let me stop share because I'm out of time. Let me get in my, I'll check my little quiz here, see if it's worthy for you guys, if there's any changes or not. It looks like number 9. I'm taking a look at your questions first to see if they're worthy of. And this would be from yesterday. So not yesterday, last week. Let's see, there would have been what, proportions and t's. I think that's what it was, proportions and t's. Still looking. Yeah, you can do that one. 5. That's a proportion. Okay, got that one. Yep, you can do that. Okay, so there's, looks like there's 6 questions. Let me open it up, make sure you guys see that. Or publish it, I guess. Hey, those of you that have your computer on, can you check to see if it's...
It's there.
Yeah, it's there.
Okay, Angel, I know you got to take off. See you later.
Thank you. See you tomorrow.
Okay, and then let's see how many we got left in the class right now. Not that one. Okay, breakout rooms here.
So I will fall under quiz number something.
Quiz 9.
Quiz 9.
Found it. Thank you.
Yep, you're welcome. Okay, I'm going to put you in groups of, there might be 1 or 2 groups of 3. Otherwise, groups of 2. Yeah, there's only 1 group of 3. So you'll partner up, talk to somebody again, and I'll be out here if you have questions. Otherwise, see you tomorrow. Or I'll be here at 1 o'clock as well today, 1 to 1:30 your time. All right, so here you go. You're on mute.
Oh,
There you go.
hi. I don't know, but Zoom took me out.
Oh, let me,
Wait.
say it again, Laura.
Zoom took me out like a minute ago, so I wasn't able to get into the breakout rooms.
Okay, let me see if I can find you here. Hi, Bobby. So, Bobby, are you looking for your partner? Yeah, that must be Laura. So I'm looking to see where Laura. Oh, so Bobby, I'm going to move you into where there's be three of you because Sarah's look. So Laura, can you see where it says join a room at all?
No, nothing is popping out.
Okay, let me figure that out. And I'm going to move Bobby into your room 3, and then you'll say, okay. You see that, Bobby? Can you join? You can't do that? Huh, interesting. Bobby, can you see Laura right now on the screen? I'm sorry, you can't. I can't hear you, Bobby. Okay. Let me go talk to Sarah for a second, okay? Figure out what I can do here.
I cannot hear you.
Good morning.
Good morning. Yeah, I think so. Yeah, I don't know what was happening, but nothing was popping out about the breakout room, and Zoom just took me out. Yeah. Should we start the quiz? I know that we're not in a breakout room, but
Sure. I mean, we might as well. So I have not been able to do my homework for 9.3 and 4 yet. So
I'm gonna let you guys work outside in the main room, okay? Other people might slide through and look for me. I'll be around. So I'll let you guys do your thing, okay?
okay. Let's see. So how many questions we have? 6 questions. Sarah, have you started the quiz?
Yeah, so I'm just doing number 1 right now.
Okay.
Did you guys already do it?
No, we were
a little bit of a struggle with the breakout rooms here.
Oh, okay.
I have not been able to do my homework for these sections because at the beginning of the week we got delayed with the class kind of being later.
Yeah.
So I feel like with work I got kind of one behind, and so now I'm kind of trying to pay attention.
Okay, so for this one, then number 1, we just have to put it on in the calculator. So you'd have to go to you just do stat, then you'd go to z-test.
Is it that one, the T?
No, the T asks you for an S. X.
Oh, okay, because we're giving the standard deviation. So let me see.
Yeah, because if you go yeah, the standard deviation is 20. So that one the z-test asks you for the standard deviation as well. So let me just calculate it. So I believe the z data value would be 1.5. That's what I have. You guys do you guys want to check or?
Yes. Let me see. Okay, yeah, that's.
Okay, assume a normal distribution p-value is in an alpha. Do you reject the norm or fail to reject the norm? So p-value, I just saw that. Solid evidence. So we do have.
Oh, that's a different table.
That would be. The p-value is.
Is that table 6 on page 514?
Table 6.
Yeah.
On the book?
Yeah.
Oh, I don't know. I didn't check.
So that
That one's on the where it says hypothesis testing, right here.
got it. So never mind.
So if the p-value is less than the alpha,
Got
which it's not, it looks like it's just by 0.01, it's a little higher.
got it.
So then we do not reject the null. So fail to reject the null.
Oh, okay.
Gotta make sure we spell it all correctly.
Yeah.
Okay.
So given n equals 26 and alpha equals,
For number 1, did you get 1.5?
yes.
Okay.
So number 3, given n equals 26 and alpha equals 0.1, h of naught mu equals 24 versus h of alternate is mu is not equal to 24.
So it would be 2.326, or would it be 24 minus 1, 23, 2.500. So how do we find out if it's, that's the one that confuses me.
Yeah, so
Secret.
I need to go back and do it because I can do it for Z crit, but not T crit.
Oh, for Z crit is what, so for T crit, it would be, I remember now, I was a little confused.
Is D minus 1.
Yeah, D minus, so D
So I mean
F
N minus
N
1.
minus 1.
Yeah.
So our N is 26, it would be 25.
25. Yeah.
It would be 25, so then it would be 0.01? 2.485?
But check that it's in the one that has 2 intervals instead of just one. There are 2.
Oh, yes, you're right. You're right. So then it would be,
That's different.
it would be 2.787.
Okay. And so just so that I'm clear on that, the DF is going to be the y-axis on that table graph, right? And so you would find the DF and then you would find the alpha and then kind of guide them both down till I find that number, correct?
So it would be, okay, so they give you alpha on here.
Sure.
So you have alpha when you go to right here, but it's area and 2 tails.
Got it.
So you go to 0.01 and then you have your, what's that called? DF, D point F point. So then you,
I think so.
yeah, so you have N 26 minus 1. So that would give you 25 right here. So you'd go all the way to that side where the 2-tailed 0.1
Got it.
is.
Thank you.
For number 2, you guys failed to reject the null.
Yes, failed to reject the null and make sure you spell it correctly.
Yes. So it's 2.787, correct?
Yes.
Okay. Okay, now. For H. It's less than 24. What does he mean by what would be your decision?
Not sure.
Like about the null? Like if we read right?
Mm-hmm.
So let's see. So it's 0.05. And give you? Oh yeah, 0.05. Okay, so that one is a Z.
I think for number 3 it should be a plus and minus.
Oh, you're right.
So it would be plus and minus. So I don't know how to write that. If we write in parentheses, negative 2.787 and to positive 2.7.
Say that again.
Yeah, since it's 2 tails, it has to be negative and positive.
So do we just put a negative?
And then comma 2.787.
So negative, comma, positive?
Yeah, well, that's how I'm gonna put in parentheses because I don't know if I should put negative slash.
Hi, Jeff. We have a
Should we
question.
ask him?
Looks like he went somewhere else. I think he's having to come out of the rooms and go back into the rooms.
We have a question on number 3 because it's Laura's saying that we need to put positive and negative, but how do we do that?
Let me look at number 3.
Okay.
I don't think that was necessary, but let me take a look at number 3.
This is 2 tails.
Yeah.
A critical, I think, is necessary.
I understand what you're saying. Don't put plus and minus. It's just assumed that it is. Just put in the number.
Okay.
Oh, okay.
That makes sense?
Yes, thank you.
Are you guys sure about number 3? So what table are you looking at for number 3?
Table D.
Okay.
Okay, so you're on that page?
Yes.
Okay, so what we're saying is that, so you see in the middle, it says area in 2 tails.
Right.
Okay, so on that section under, you're gonna look for 0.01. It's all the way on the right side.
Got it. I kept going into the 2 tail, like 0.05 column.
Oh, okay, yeah. So you're gonna go 0.01, but because it's it's a T interval, right? I mean a T. What's it called?
T crit.
T test. Yeah. So because it's a Z test, sorry, I'm confusing you. Because it's a Z test, we're going to find the D point F, which is, what's the name for that?
Degrees of freedom?
Yes.
Got it. Okay. So I was looking in the area 1 tail because I didn't.
Oh, okay. Yeah. Yeah.
All right. Are we on number 4?
Get, for number 4, did you calculate it?
No, I haven't done the homework yet, so I'm.
Oh yeah, yeah, that's fine. I'm just saying because I got P equals 0.050. So then we would find if it's we reject the null or we do not. So then that would be your alpha's 0.05.
Aren't they equal? It sounds like equal.
Yeah, it's just pretty much the same. But
since I'm giving S, that's a Z interval, right?
What was that?
Since I'm giving S instead of X bar,
yes,
that would be a
T interval. T test, yeah.
A T interval.
It's not. I don't think it's interval. Okay, so that one would be He is, well, that one's a little higher, I think, because it's 0.0508. So it would be, would it be higher than 0.05 alpha, right?
Yeah.
Just by like 0.008.
Right.
Okay, so then that would be, we do not reject the null. I believe. Laura, do you agree?
Yeah, well, I'm still working on it.
So would that be fail to reject the null then?
Fail to reject.
Alpha 0.05. So I got P equals 0.051.
What did you get? Sorry.
For P, I got 0.051.
Oh, you got 0.051?
Yeah.
Okay, that's different.
What did you get?
I got 0.0508.
Yeah, so just round up the 8 to 1.
Okay, yeah. See,
So P will be bigger.
so then it does, we do reject the null. Then, I mean,
Yeah,
then
because-
do not reject the null.
Okay, so
So-
my question is in the wording, do we say do not reject or fail the reject?
Well, here, I think it could be either or, because on the book, on the reader, here on the bottom,
Okay. Got it.
it's on the hypothesis testing. It just says chapter 9. It's the beginning of chapter 9.
Can I see how you wrote it in the book again? Or it was written in the book, because spelling matters in these things.
Yeah.
Do not reject
Mm.
the
Do
null.
not reject the null.
Okay. So did you guys write it in that little box the same way it was shown in the workbook, or how did you write it?
I think it doesn't matter, because I think he gives you different options now of how to.
Mm-hmm. You're right.
That's the thing.
I just feel like there's a lot of combinations to write that out.
Yeah. Okay.
Please do, Jeff.
Oh, sorry, we got kicked out of ours, so we're here working on it.
That's fine.
Which is kind of odd because we're being recorded. So
Yeah.
Oh.
Oh no, we don't. I think after 9 we don't, because I've seen the other classes and
it's recording right now. I can see that we're being
Oh
recorded.
really? Oh
Yeah.
yeah.
Yeah, it says recording on your top left if you look at it. Jeff, can I talk to you for a second?
I think he's in a breakout room.
Mm-hmm.
For number 4, guys, and if you did
We're
it,
doing it right now.
Yeah.
because it doesn't say normal anywhere, and it's already there's already sigma over there. Let's say yes, and the sample is only 26. I said we can't solve it, but that was not the answer because
Yeah, it's do not reject the null, I believe.
yeah, I knew that was going to be the answer, but I said we can't solve it just because this
Because
n
n
says
was
26, and it doesn't say normal anywhere.
Yeah. Well, pretty much because none of the homework gave that, even if it didn't say it was normal, and even though n was still lower than 30, it like never said, you know.
Not
I think
I saw in one of them.
I think we were just confused on that because he did say in other occasions he was like, don't solve if it says less than 30, but here he didn't, even though the book kind of doesn't say that, or the notes doesn't say that. Do you understand
Because
what I mean?
in one of the homeworks, in one of the questions, it's similar. The n is, I think, around 12 or 13.
Yeah.
And they have still solved it. I haven't solved it. I wrote it, we can't solve it.
Yeah, I
Because
did
that's how
solve it
Jeff
because
does,
I was
yeah.
like, because none of them said that, even though there was some that were less
Yeah.
than n. Okay, let's just do this 5 and 6 really fast. These 3 important.
Is left hand.
It would be left.
Mm-hmm.
Yes.
Yeah, because it decreased, so it means that.
Yeah, you're
So
right.
open it up.
One, A, perfect. And then number 6, a study report.
It's a 0.05. This is not given.
P hat.
Ooh, P hat. That's from like 2 chapters ago.
No, that's
Oh,
from 9
shoot,
point.
if they're talking about alpha. Oh, that's when you do x over n.
Yeah,
That's from 8.3, guys.
yeah.
Yeah. So x over n.
So it'd be 85 over n.
Over 500.
Yeah, over 500. Point 17.
That's what I got too.
And then there's 100.17. Yeah, 0.17.
Nearest hundreds. Point 17.
Yep, so 2 decimal places.
Yep. Okay, there we
So
go.
0.17.
Yeah.
Okay.
All right, are we ready?
Yes.
Oh. Let's see.
I got 8 out of 10. What'd I get wrong?
Oh, I got 6 out of 10. What did I get wrong?
Oh,
my
shoot.
God. Oh, I put we.
He'll give us back number 4.
Yeah, but yeah, me too, because I just put we. I don't know how that went. On number 3, I put we 2.787. I don't know how that, I typed that in on accident, I think. Okay. Yeah.
I got 8 out
all
of 10.
They're
So-
all right.
So number 4.
I said do not reject the null.
Yeah,
Yeah.
that's still fine.
He'll give it back. You just gotta let him know.
The book says that. The reader says that.
Yeah.
Okay, we're done then. Jeff, you can come back. Oh my God.
I don't think he can listen to us right now.
He's still there. He just put the computer down, the
Yeah.
screen down.
Yeah, what I do is I just take a screenshot and then I just send it to him through email.
Probably grabbing a coffee and taking a quick break.
Yeah.
I mean, 2+ hours of talking is hard.
How did I get 3? Like, really? How did I type that in if I had my answer correct?
It happens.
Mhm. Oh, he is here.
How do we get him to come back?
He'll probably come back when he's done with his break.
Yeah.
He should be back by now, I think, because he has a class at 10, so
Yeah.
it's 9:35 already. So
Jeff.
Oh yeah, he's back. Hi Jeff.
We're done.
Yeah.
And then zoom in.
Yeah, that's fine. If you just enjoy hanging out and talking,
Right.
that's fine.
We have a little question. We put do not
Or-
reject the null, and then on your options you just had don't, fail, or
Oh. Yeah, see, I can't come up with all the options.
yeah. But
Do
you know
not-
your reader has that, so we just put do not
Okay.
reject the null.
That's not a big deal.
And then on my question 3, I had it right, but I don't know how I typed in WE before my answer. I think that was like a little.
Okay, let me do this one at a time. Get back up here. It looks like I'm staring at you, but I'm actually looking at your grade book too at the same time. Okay, we'll do Sarah's first.
Thank you. Sarah
Mine too.
Maldonado.
You
know
are
the
right.
other
I
two.
know your last name, Sarah. Bobby Lance. Laura. I think the
Laura.
last name is
Laura.
like with V, like with letter V.
No.
Suman. I know I know a lot of people's first name and some last names. Let's see. I'll go scroll down here. Sarah. Where did the WE come in? That was
I
weird.
don't know, but I don't know how I did that. I saw that I put it in right.
Okay. Give you 2 points on that one. And then the other one, do not. Oh, yeah. Okay, yours is changed.
Thank you so much. Thanks,
Awesome.
girls.
Bye.
Bye.
Okay, Bobby, you're next. Let's see what's happening with yours.
Number 4, I couldn't figure out how to write it in there, and I put it in there the way the notebook said, and it wasn't accounted for. So
Right, I didn't put the do not. I just put don't. So that's, yours is right. So putting 2 there. Okay, I've just changed yours.
thank you.
And then Laura.
Yeah, same thing with for number 4. I put do not instead of don't. Same thing.
What's your last name? Start with Laura.
J. Hohua.
Oh,
J.
Jay. Okay, thank you. Oh, yeah. Okay, there you are. Okie dokie. So you're taken care of too, Laura.
Thank you. See you tomorrow.
Welcome. Okay, Suman, looks like you and I.
Yeah, on number 4, Jeff, I wrote the answer as we can't solve it because 1, you didn't say it was normal. 2, S was given, and 3, N was 26.
Okay, let me
I
take
knew
a
that.
look.
Yeah, go ahead and look.
This is problem number 4.
Yes, Jeff.
Sometimes the book, I get what you're saying, and good job on that, because what would your decision be? But only if you could work it out. Sometimes a book will put these kinds of problems in, and just to see, but they don't say assume normal. And so I'm going to leave everybody else's results as is, but yours, you can't solve. What if it was normal? What would you have said?
It was going to be do not reject the null.
Yes, okay.
I think Sarah also did the same thing with me, I believe. I'll let her know that she can talk to you about that. Because on the homework too, there's one of the questions similar to this one. The n is smaller than 30, and I looked at the back page, it's solved, but I didn't solve it, and I wrote the same thing as yours. We can't solve it since n is less than 30.
I understand. No, you did good. On the next go around, just to make sure that it's not exactly like the author, I'll add assume normal.
Yeah,
Just
if
that-
just that was the word, then I would have written, okay, do not
Yeah.
reject the null. And I saw that and I was like, okay, we can't solve it. Even though Jeff has given it, I can't solve it because n is less than 30.
Makes sense.
And I don't know the last name of Shara, but I just know for her first name, it's Shara. She was in, I don't know her roll number. She did the same thing as mine, but I'll let her know that she should talk to you about this.
Yeah, have her come talk to me. That way we can have a chat about it if you have her contact number.
Probably I'll see her tomorrow. Then I'll let
Okay.
her know in the chat that you need to talk with Jeff about the 2 points.
Okay.
All right. Thank you, Jeff. I'll see you
You're welcome.
tomorrow. Bye-bye.